right, looks like we're still getting a few people in. Thank you very much for joining us. Thank you for taking time out of your day. One thing before we get started, I'm just going to go through a bit of housekeeping here. So the webinar is going to be recorded. If you'd like to revisit it or if you'd like to share it with other colleagues, please feel free to do so. We will be sending that out after the webinar, so you will be getting a follow-up email with all the recording. Your questions are very much welcome throughout this session. Hallucination is a topic that we know that everyone is struggling with, and they're trying to understand how to make sure that, one, they understand it, and two, how to prevent it. And we will be going through a lot of strategies in terms of what kind of hallucinations you could run into, as well as how to prevent them. So please make sure that you're asking questions along the way. We'll try and address them as we talk through things, but we definitely have a dedicated time at the end of this section to make sure that we're addressing all of your questions. All right, so to get started, I'm Lisa Aguilar. I'm our VP of Field CTOs and Product Marketing here at DataRobot, and I am joined by Justin Swansberg. Justin is our VP of Applied Data Science AI Experts, focusing on all of our major accounts. So he has seen everything that every team has probably ever tried to do when it comes to data science teams, both large and small. So an excellent resource here who's going to be sharing a lot of his experience and expertise where he's seeing things gone wrong, and hopefully you can take a lot of that knowledge and be able to apply it in your own journey here. So definitely do not miss the opportunity to ask your question as we go through this. All right, so what are we going to talk about today? We've already went through introductions. We are going to try and convince you that hallucinations are actually good for you. I know that sounds like a bit of an off idea, but there are things that you can learn from hallucinations. They will teach you. And so we think we're going to convince you of that. We're going to walk through some of the hallucinations that are going to impact you the most. So what kinds of hallucinations you're most commonly going to run into, and then the strategies to take against mitigating these hallucinations. And then what you want to do in terms of how you're thinking about your generative AI applications, the entire workflow and the life cycle. I don't think we're going to have time for a demo here, but we can talk through, we are going to throw some screenshots of DataRobot and how we can help you do some of these things. If we have time, we may do a case study, but we know our questions tend to go a little bit over, so we will make sure that we get to those first. All right, so a little bit about DataRobot. DataRobot is a pure play AI software. Very much we are sitting on top of your existing ecosystem and infrastructure to help augment what you are trying to do with AI. So the biggest focus of DataRobot is, one, helping you actually embed AI into your business fabric. That is very difficult and challenging to do. And the second thing is to actually mitigate and manage your entire risk profile when it comes to AI. And it's really funny because a year ago, we probably would not have talked about AI risk as much as we are now with generative AI. Hallucinations are just one of those risks, but there are a multitude of other risks that you do need to manage for. We've been focusing on nothing but AI since our founding. So we have a decade of experience really looking at how to actually take AI and not in an R&D perspective, but realistically how to apply it to real world business problems. So we've been battle hardened over the course of over a decade in terms of what we've been focusing in on. So we didn't become AI over the time. Generative AI has not turned us into an AI company. We've always been one, which means that we actually have a very solid and strong foundation in terms of ensuring that you can build quickly, operate, and then manage models effectively in production. The biggest thing to me about DataRobot for us is the customer recognition that we do get in terms of how we are helping our audience and the economical, societal, and organizational impact that we are having. So the DataRobot platform, as I said, has been battle hardened, that we are used very strategically in organizations as well as to things that are actually impacting us on a day-to-day aspect from the economy in terms of 1/3 of the foreign exchange going through DataRobot. One of my favorite stories is also that DataRobot has been used in terms of traffic on border controls in terms of helping to protect and prevent actually drug trafficking. So very different types of use cases that can be applied with DataRobot, but always very impactful to the organizations. All right, let's see. It looks like I have a question that's coming through. Perfect. Yes, we are going to record this. You are going to get it if you joined a little bit late. A little bit about DataRobot and where we sit. So think of us sitting as right between your system of record and your system of engagement. As I said before, we're really about making sure that you can bring your AI applications and solutions and quickly weave them into your business process. We know that's not easy for a lot of organizations. We are unified in terms of being able to balance between predictive and generative. You can volley back and forth. And the biggest thing about DataRobot is being able to help you collaborate across that build, operate, and govern capabilities with our AI pipelines that just make it very easy for you to maintain the integrity of your AI applications and solutions and quickly get them into your business processes. We're extremely open. So if you like to build in another tool, no problem. If you have some open source tooling that you want to use, no problem. It's your choice. Okay, that's enough about DataRobot. Let's get into the meat of things. Why LLM hallucinations are great for you. You know, Justin and I always joke about this. It's a very non-common thing, but they are actually good for you. They will teach you a few things. So I don't know where everybody is in terms of their expertise. We're going to start a little bit basic, but we will get into a little bit of depth here. So hang on with us if you're a little bit more advanced here. So first thing is LLMs are really just guessing. They don't actually know the answer to a solution that you're getting. So they're looking at the probability of what the next word will be. So in this case, you can see it's predicting what is DataRobot. DataRobot is the leader in getting value with AI. And then you are stringing all of these concepts together to get an actual output. Now, LLM hallucinations occur because large language models are generating information. Now, I like to think of them as little kids. They are designated to give you an answer. So if they don't know an answer because their world has never been exposed to it, they are going to create one for you. The other thing is they're going to take parts and pieces of information that they think are correct, and they will actually curate an answer for you. So you have to do a couple of different things when you are working with LLMs. One is you want to make sure that the world that they're being exposed to is the world and the business context that you want them to have exposure to. The other thing is you want to make sure that in terms of how you're building out your applications with using generative AI, that you are looking at how creative and the creative liberties that you are giving your generative AI applications, which Justin will dig into. Now, just like a child, these aren't deliberate errors that they are trying to make. Also, just like a child, you want to be careful because the data that you do introduce to an LLM, they are going to remember. So a fun analogy is think of a small child. If they accidentally hear a colorful language, they're going to remember that colorful language. So it's better not to expose them to that colorful language because they will want to use it. So that's another thing that you want to make sure that you're looking at when you're building out your RAG applications. And we'll talk through some strategies there. Now, some hallucinations can be really, really obvious and very apparent, which is easier to deal with, especially if you're building generative AI applications for business users. They can start to filter through some of this information. So one example that we have here is Justin literally asked ChatGPT a while ago, what was the world record for crossing the English Channel entirely on foot? And one of the funny things is just like a child, it made up a story. Not only did it say how long it would take, it would say that this is actually very dangerous to cross the channel on foot. It's extremely challenging. It gave a name and it gave how long it takes that you would be able to do this on foot. Now that is very obvious. For most people, they could understand that contextually this isn't correct. But there are some hallucinations that are not so obvious. And this is where it becomes really challenging for all of you who are trying to build effective generative AI applications for your business users or your customers and consumers. So this is another example. Justin actually asked, can you give a short paragraph? And he made up an entire data science strategy here. And you can see that ChatGPT actually gave a response for what this strategy could be. And not only did it do that, but it actually gave code for how to implement this strategy inside of your workflow. Now, if you were yourself not a highly trained data scientist, would you actually know if this was true or if this was false? I mean, if all of you have experience with this, you would understand that this is not necessarily a real data science technique or strategy. But think of this in the context of somebody who may not have that depth and level of experience or expertise in some of the information that is being provided. So this is where hallucinations can be quite dangerous. And these are the ones where what we're seeing is a lot of organizations really struggling to control and effectively fight off. And then what are the strategies you can do here? So we've all heard the saying before, all models are wrong, some are useful. What you really want to start thinking about, especially when it comes to generative AI, is all LLMs hallucinate. And yes, there are some hallucinations that actually can be useful to you. So you're probably thinking, like, why can hallucinations be great for you? So hallucinations can tell you two things. First and foremost, hallucinations are actually going to tell you how mature your pipelines for AI actually are. And this is an interesting thing. If you're not effectively able to catch, mitigate, and intervene on hallucinations, then that's just letting you know that the tooling set that you're using right now is not mature enough for you to actually be able to produce these and create true value to your organization. So you do want to use this as an indicator on how well your processes are set up. The other thing that LLMs hallucinations are going to tell you is how well are your monitoring, observability, and views that you have there, and can you forensically dive in to figure out where the hallucination is happening? So what a hallucination will tell you is where in your infrastructure pipeline and your process needs a lot of your attention. And this is some of the things that I think we haven't been used to. This is very new for data science teams and organizations in general. So you're very much used to, if you build a prediction, it's going to work, data is going to drift. It's very different, those kind of pipelines, than it is when you're doing a generative AI. So it's not enough to have good tooling set that you're stringing together. You really have to take a look at how that's coming together and then using the LLM hallucination to tell you where you're having weak spots. Now, the hallucination types can also tell you what type of hallucination that you're running into, so you can build better hallucination mitigating strategies and techniques, and then how to catch them in production. So again, you want to make sure that you're looking at the full life cycle. So you're using a hallucination to tell you where you have gaps, and then you should be able to go forensically look at that and then go back in and then mitigate your strategy on there. Now, there's a lot of different hallucination types, and there are definitely mitigation strategies. Justin's going to dive into a little bit more of the hallucination types and the mitigation strategies here in just a bit. But a couple of the common hallucination types that you're going to find is input conflicting, context conflicting, and fact conflicting, and then forced hallucinations. Justin, do you want to add in a little bit here before we dive into your section?
I think that if we take a step back, what Lisa and I really want to express throughout the entire presentation is really twofold. One is that these language models, they really are going to answer whatever question that you ask. And that can be a good thing because sometimes you do need to invent an entirely new answer. And if you think back to the code example, sometimes you actually do need to produce entirely novel code. It might actually, the situation may dictate exactly that. And of course, there are other examples where you want to make sure that you are grounding all of the different answers. And so this slide really speaks to the fact that you need to understand the different error modes effectively that these language models can produce in order to know what to look out for when you do promote something to production. And so what I'll walk you through after is that once you get a good handle on the different ways that these language models can fail, or the different types of hallucinations, because one big mistake I see is that people think that all hallucinations are the same, when in reality that's not true. If your model suffers from a particular type of hallucination, you actually need a different mitigation strategy in production. So step one, I always say, is figure out the different ways that your model can go wrong, and then custom build different detection or mitigation strategies that know to look out for that exact type of error mode.
All right. So one of the things that Justin just brought up was sometimes you do want hallucinations depending on the use case that you're working for, because it's basically the creativity that you're allowing your large language model to do for you. So you can think of it in the context of if you were generating a storyline or a script, you may want a lot more creativity in what's happening. So those kinds of hallucinations and being able to draw upon different patterns may be much better. But if you're looking at something quite serious in terms of your customer engagement, or you're looking at helping to reconcile what you have or look at what's going to be possible in the future with forecasting or next best offer, that's when you're going to want to take a little bit more control on balancing that out. So let me pass this on to Justin to talk a bit more about that strategy and how to think through it.
Perfect. And I do love this image. I want to start though. These, like we've already established, the language models here, they're very subordinate. And I like to think of the whole problem of hallucinations more as a feature and less as a bug. Like Lisa said, you actually do want to promote creativity. Oftentimes, the best answers need a certain degree of creativity. And so what this picture here is highlighting is the inherent tension or trade-off between encouraging that creativity, but at the same time trying to ensure that there's as little chance for the answer or the output to be incorrect. So it truly is this balancing act where the more you limit or suffocate the model's ability to be creative, sure, the more you can protect against incorrect answers or hallucinations. But again, it's a double-edged sword because then you're going to get worse answers. So if you go ahead to the next slide for me, a really good illustration of this is a common use case that we've rolled out across a lot of our clients. In this particular case, we start by predicting the most appropriate next best offer or recommendation for an organization. Imagine you've got some type of cross-sell campaign. And we can take all of the different reasons or the explanations why we think a particular customer or company is a really good candidate for what we're trying to sell. And we can craft a highly targeted or personalized email that actually incorporates those unique factors or explanations. And in this case, if you want the customer to likely reply to the email and make sure it's highly customized, you definitely want to encourage a high degree of creativity. I'm sure everyone's inboxes get flooded with a whole bunch of incoming outreach, BDRs, sometimes even spam. You need to actually look different to separate yourself. And so that is, again, a feature of this process. But at the same time, you can't let these models get overly creative and make up information about, let's say, the details of the offer or your company or even the pricing. And so what I really want to leave you with here, the entire idea actually of what Lisa and I are proposing is that you actually can have the best of both worlds. You don't want to suffocate your language models by inhibiting their creativity. You want them to be fully creative, but on top of that, you need to then closely monitor the output and set up what we call these guard models or screens or filters to make sure that you're checking for all these different types of failure modes. And if you go to the next slide for me, what I've often seen is that most folks are overly focused on looking at the performance of language models in isolation. And you've probably seen all of these academic articles and posts on LinkedIn about how factually correct language models tend to be. In fact, there's a bunch of benchmarks. And every time a new language model is introduced, let's say Google introduces a new version of Gemini, OpenAI introduces a new version of GPT, people tend to look at where they rank on these leaderboards. And there are all of these pre-baked tests, these benchmarks that have a bunch of representative or hypothetical questions and answers where we can somewhat more objectively test if the language model's answers are technically correct. But the problem is, at least from my perspective, the whole approach is flawed. Any language model can actually be influenced to output whatever type of answer you'd like. In fact, no matter what you do, there's a certain degree of what I call irreducible error. Models are always going to hallucinate no matter what, and we shouldn't be overly focused on trying to decrease that hallucination rate to zero. Again, why? The further we push that down, the more we inhibit the model's ability to be creative and actually usefully solve a lot of these answers. Think of it like a seesaw. There's this inherent trade-off between usefulness and correctness. And so you want to find the right balance. You want the models to be as useful as possible, and then add these guards. And so what I always suggest to clients we work with is rather than focusing on the language model in isolation, focus on the end application, the entire system. Because when you deploy these into production, you're going to have what the community is now calling guardrails. Think of this like a way to babysit the model's output, to extend Lisa's earlier child analogy, that are going to monitor the output and then flag or detect any instance of these hallucinations. And what you should care a lot more about than how well a language model can perform according to these benchmarks is how well the overall system performs. Again, you want to make sure that the language model produces useful answers, as useful as possible. But when, because sometimes you turn that usefulness all the way up, it does get an answer wrong, you've got the right guardrails in place to alert that and then also intervene or mitigate that and moderate it in real time. So I want everyone to change their thinking. If you go to the next slide for me, Lisa, from a chart like this that I'm sure you've seen, it's made its rounds, where you simply say, how accurate is this model according to probably in a somewhat unrealistic set of highly curated examples, to the next slide here, which is, all right, you've got a fully operational, fully working system in production. Here we go. And you're now monitoring how useful the answers are that make their way back to the end customers. That's really the key. So with the DataRobot platform, we help you set up all of these guardrails, and we help you compare and contrast not just the individual language model, but the entire end application, the entire chatbot, the entire chat interface. And so here's an example where you can actually include or attach some of these guards that will detect the different level of confidence or the potential rate of hallucinations. In fact, you don't just look at some of these more objective measures. You can also bring user feedback and solicit information from humans in the loop to actually capture that and incorporate it as part of your guard process as well. Now, let's talk a bit more about the different types of hallucinations, and then we'll actually dive or double click into the different guards that you can set up. The first part here is that, unfortunately, there is really no single silver bullet. There isn't one way to automatically catch or detect all the different possible failure modes. The best way today to go about making sure that you build a safe system that you can confidently deploy is to set up what I call multiple lines of defense. And each of these columns or pillars here in blue, you can think about as a screen or a filter. So it won't block all the different issues, but it will block some. And if you stack all of these screens together, so you add a bunch of different guards that serve different purposes, you will eventually filter out all those errors and make sure that your entire system, your language model, only produces appropriate, correct answers. And when you go about setting these up, there's actually really a large diversity of different types of defenses or screening filters, and DataRobot supports them all. But again, the key is that it requires that you build a lot of different types. So some of them can be simple rules-based models. You can check for the existence of certain keywords or tokens, as an example. You can run a lot of Pythonic scripts that just check for readability, a lot of tests that have been around for decades now. You can also get a little bit more creative and build predictive models. It's a great example actually of combining or blending together predictive and generative. You can think of a predictive model actually sitting on top of your language model, making sure that it closely monitors the behavior. Again, think of a predictive model babysitting a generative model. And then just because that's not crazy enough, you can also have generative models babysitting themselves. It's one language model actually grading or monitoring the output of another language model. And I'll actually dive into some of the different ways these strategies work. So if we advance the slide one more time, we mentioned, or Lisa mentioned, 4 different hallucination types. And the reason this is important is because you actually want to set up a different set of guardrails for the different types of hallucinations. There isn't just a single type of hallucination. It's a bit of a misnomer. And one of the reasons that we are trying to convince you all that hallucinations can be useful, not just because they always happen, there is this irreducible error rate where no matter how, again, feature, not a bug, language models are designed to answer your questions. And oftentimes those answers. They weren't designed to produce ground truth. They were designed to produce likely tokens, likely next words, reasonable sounding answers to your questions. And so if you want to set up a robust system that catches these errors in production, you need to actually see examples during training of all the different ways that the model can go wrong. And we'll talk through this in a second here, but the idea is to have a pretty detailed system where you collect information on all of the different hallucination types so that you know what guards to stand up in production. And the 4 types here are input conflicting. This is when the language model's answer, it actually contradicts or deviates from the instructions that a user provided. Think about all of the text you input into the prompt. Context conflicting is similar, except that it looks when language models, they produce output or generate content that conflicts with their past answers or anything that they've previously generated. You imagine you're having a conversation, you ask a question, the language model produces an answer, maybe you follow up. You need to make sure that there's alignment across the different answers. And then the third and probably most well-known is fact conflicting. This is the idea that language models produce some answer that contradicts a well-known or highly regarded fact, something about general knowledge that we all know and agree to be true. And the fourth one that's often left out is the idea of what people call a prompt injection or a jailbreak technique when a user tries to override the model's explicit instructions. And again, each of these different types requires a very different guard in production. So if we go ahead here, the way that this works under the hood in the DataRobot system is that you have to select the different guards and you figure out which combination you'd actually need to apply in production by digging into the details during the testing and development phase to figure out the different errors and then what guards are appropriate to address those errors. And when you have them, you apply them either to the questions, the answer, or some intermediate step. So some guards could be blocking information in the user's question. Let's say the user is trying to input some malicious prompt. They've got some toxic language. They're mistakenly or accidentally disclosing some confidential or sensitive data. You want to make sure that you've got a guard stood up there to block that. Similarly, on the response side, you want to make sure that if a language model, rather, produces an answer that is digressive or low quality or incorrect, rather than sending that back to the end user and making sure that that experience is quite poor, you want to prevent that altogether, catch that. But again, you're not changing how the language model works, you're just adding some guardrails at the end of the process. If we skip to the next slide here, so again, this is a double click into each of those individual guards. I just want to go through 2 or 3 quick examples here so that we're all on the same page. Let's imagine that I am simply asking the chatbot we may have set up a question about how to log in to one of my systems. And I'm asking about a particular password that's not working. Obviously, that might be or is likely considered PII. So one of these guards you can set up could just detect exactly for that. And you can see here, we're actually going to catch that in transit so that the particular password doesn't get leaked outside of your environment and then saved down to the language model. And it's really important. In fact, the other thing about these guard models that's probably not apparent here, but is arguably the most important piece, is that all of these guards need to be customized. So what I deem to be PII for a certain use case might be entirely different than what any of you deem to be PII. So you need to actually work within the guard to help adapt it to your particular use case. So maybe you are okay disclosing names and disclosing locations, but you're not okay disclosing something like financial results or passwords. That's on the prompt side. If we skip ahead, we can look at the response side. So the user's question makes its way all the way through to the language model. The language model provides an answer. Here, in this case, we were doing work for a large hardware provider. And the language model, let's say, answers a question about the cost of a particular piece of hardware or a part on the machine, and it gets it wrong. And it can get it wrong for a variety of reasons. It can just invent a price that doesn't exist, or it could reference a price that might be outdated. Here, there's a bunch of different ways, and we'll actually review a few where you can have guards attached to the response to make sure that these errors are also flagged before the answer makes its way back to the end user. And in the DataRobot platform, you can actually customize these messages or build some more advanced flows that will provide feedback to the language model saying, hey, you got this wrong. Here's why. Can you try and take another stab at it? Until the answer has a high enough confidence that you can pass the response back to the end user. And then one more slide ahead here for feedback. Again, this is often overlooked. As users interact with the system and provide feedback, we can incorporate that feedback directly into the language model or even the RAG process if it's a chatbot here, and then make sure that we force the language model to update over time so that its answers are more and more aligned with what the end users expect. And this feedback, it actually is built into a predictive model. And it's another reason why capturing hallucinations are so important. So if you go through and capture information about certain hallucinations, or if you provide feedback, even as simple as thumbs up, thumbs down on all of the answers, you can then build yourself a training data set and leverage traditional supervised machine learning to actually build yet another guard. Effectively, you're going to anticipate the user's reaction or the user's feedback, and then prevent any responses from making their way back to the user that you expect the user would downvote. Okay, so this is probably the meatiest slide here. What does this actually look like in DataRobot? Why do we care? How do we actually defend against hallucinations? Now that we know they are here to stay, we don't want to get rid of them at the language model level. We want to get rid of them at the guard level. Well, we've bucketed the different types of guards that you can apply into these 4 different categories: cost, safety, quality, and correctness. And in the DataRobot platform, once you actually have a language model or a chat app or a RAG pipeline built, it's as simple as coming into the UI, the interface, which you can see off to the right here, and just picking and choosing, quite literally clicking on any individual card that you want to apply as a filter. So it is actually a 2-step process. It is choose your guard, and you'll likely want to choose a whole bunch of them, and then decide whether it applies to the user's question, the language model's answer, or both. And it is as simple as that. I want to mostly focus on that bottom right quadrant, the correctness. I think that is probably the biggest one for hallucinations. Obviously, with guards, you can monitor a lot of different response metrics. But in terms of the correctness of the answer, there are a bunch of really innovative techniques, especially with these language models, knowing that they are designed to produce novel content, and they're quite eager to respond. If you ask a question, they will always respond with an answer, whether or not it's the answer that you wanted. So for correctness, a few of the ones that are likely most interesting or relevant have to do with how the output is actually generated. So the first one for RAG pipelines, and for those of you that aren't familiar, think of RAG as a way to leverage your own internal data to provide additional context to the models that they may not have seen during training. So if you were to ask a question, you can actually reach into your own internal knowledge base, grab relevant information to that question, and then pass that and the original question to your language model. So one of the more common techniques to detect hallucinations is actually to ask, like I mentioned earlier, yet another language model if the answer the original language model gave was correct or not, or it was factually justified. Is there enough evidence that we pulled from your internal knowledge base to support the answer the original language model, provided? There's some other techniques here as well. I'm not sure if folks have heard of self-check GPT. The idea here is that and the reason that we're talking about this, I should have begun with it actually, is that these models are non-deterministic. This is not like some traditional machine learning models where there is a fixed relationship between input and output. If you know that the input you're supplying to the model, you can guarantee the output. In this case, there is a large degree of randomness. In fact, you can ask the same question multiple times and get back different answers. It makes it really hard to QA this process or even red team it. But you can also use that randomness to your advantage. You can look at the likelihood of every token, every next word these language models generate, and the lower the likelihood, the more likely that the model is drawing outside of the distribution it was trained against. So the less likely its answer is to have come from some grounded context in the training data. Which means the more likely in some contexts it is to have hallucinated. Again, sometimes that's good, sometimes that's bad. The other way that self-check GPT handles this is it actually just runs the same query through the language model or the pipeline multiple times. So imagine you get 10, 20, 30, 40, 50 answers for the same question. You can actually then evaluate the degree of randomness, how different each of the answers are. And the larger that distribution, then the less likely the answer might be to have been correct. So a lot of these innovative, clever techniques actually detect these. Again, the big problem is that you never know which of these is going to work the best in production. And the only way to really make sure that you've got a well-defended system with the appropriate number of defenses is to actually observe and collect all the hallucinations during training time, categorize them, and then pick and choose the correct metric. So it's a big game of trial and error and testing. And you'll never get it right if you don't actually observe hallucinations from your models early on, which is another great reason why Lisa and I are trying to convince you all or argue that hallucinations are important, because no matter what, they're going to happen, even if you pick a model that is where the incidence rate is lower. They're going to happen, so you may as well be ready for them with the right guards. All right, moving on. I said that was a meaty slide. What happens next? I've got the right guards. Well, in DataRobot, you can actually then choose if you want to apply that level of moderation. And this is the big part. Most platforms are just going to provide visibility. You will get an alert saying, hey, your language model produced a hallucination. It errored. It gave you some incorrect answer, which is helpful, but not that helpful because the error is still there. With DataRobot, you can actually set up this intervention. So in real time, you'll catch the error, prevent it from being sent back to your user, avoid that poor user experience, and you can actually customize what happens next. So on this screen here, you're seeing where a user can actually input the appropriate message. So if there's a hallucination, or maybe even a better example, there's PII detected or a prompt injection, someone's trying to overwrite the model's explicit instructions, you can configure a message saying this behavior it actually violates our terms and conditions. Please try updating your prompt. And then finally, once all of this is done, you have before production to go through and assess how well it works. So this goes back to the point I just made about making sure you diligently collect all of the information so you can understand the different types of failure modes or hallucinations during testing, and then actually run automated evaluation. And this is going to help you ensure that you do detect it on the tail end. So you've got to identify it up front, build prevention strategies, and then make sure those all come with you when you lift and shift your model from dev to production. So in the DataRobot platform, there are a bunch of ways here across the development lifecycle to make sure that you can replicate a production scenario and actually test for how many of these failures you'll catch in production. It also helps with this feedback loop, this iteration, where you can try out different guard models and try out different configurations of each guard model until you tune or calibrate it just right, so you've got the appropriate guards that defend against the different hallucinations relevant to your use case. And then finally, I'm going to go to the next slide. You've got to take all of this, push your model to production, all those different screens or filters, and make sure that you then track and monitor all of this over time. So for every individual guard model, independent of the type, the underlying strategy, you want to be able to look at some aggregation over time to see how often these different alerts are firing. And you always want to be able to then double click into the actual questions, answers, filter down to certain hallucination types, and then review the underlying data points, especially for some root cause analysis. You want to figure out how can I replicate or replay this particular error so that I can go and make my entire process a little bit more fault tolerant next time. And that really wraps up the end-to-end process here. So just to recap here, I want to touch on 3 points that we hopefully highlighted. And the first is that these models are actually designed to hallucinate. That is the usefulness. They are, when they were trained to be creative. And if you want to stifle that creativity, you might reduce the hallucination rate, but you are also going to reduce the usefulness. So we like to say that hallucinations are inevitable. These are features, not a bug. The best thing that you can do is to build these filters that catch the hallucinations in production after the fact, so that you aren't going to suffocate the models or limit the model's creativity. The second piece here is that in order to actually know how to build the right guard models for your use case, and every use case is going to require a different set of guard models, you need to understand the different ways the language model hallucinates. So you actually have to collect all of that information during testing. And then once you have all that information, you're going to need to almost certainly build a bunch of different types of guards that catch the different types of hallucinations. Again, there's no single silver bullet that will catch all these different error modes or failure types. You're going to have to leverage a bunch of different strategies and combine them all together. And that really wraps up what I wanted to share.
Great. And we have time for some Q&A. We've got our first question here, Justin. How much latency does this introduce when giving a response to a user?
Yes, this is a great question. So it really depends. I'll talk through some examples though. The first piece is if you don't have that monitoring system set up that I mentioned, and you are applying 8, 9, 10 different guards, it is actually really difficult to diagnose where the latency is coming from. And I've lived this, it's a real pain. So if you have a lot of these guards in a system set up and you realize the latency is spiking, if you can't drill into the different pieces of that production pipeline, you can't identify which guard or which language model is actually responsible for the spike in latency. I'll also say that it depends on the guard type. So if you're using a language model to babysit another language model, those tend to introduce the most latency, especially if it's an API call out to one of the closed sourced vendors. Your data is leaving the network, it's being processed on, let's say, Microsoft servers, Google servers, and being sent back. That could introduce anywhere from a half a second to a second of latency, depending on the number of tokens you send. The other ones tend to be a lot faster though. So one benefit of the rules-based models and the predictive models is that you will train a really small model that you can run locally that will give you super low latency. And that can be in the order of sub 50 or 20, even sometimes 10 milliseconds.
Excellent. We have a
Yep.
We have a lot of good questions coming in. Please ask. These are great. As you can hear from Justin, he's had a lot of hands-on experience in this, especially working with a lot of clients and customers who are doing this. So he's already learned all these hard knocks for you all. Okay, there is a question about implementation of the guardrail system. Is it possible to use these modules locally, or does the data need to be uploaded into our servers and accessed through our UI?
If by ours you mean DataRobots, the answer is we can be flexible. And that is a cornerstone of our philosophy here. We want to make sure that you don't just have to run all of this AI in our cloud. You can also run it in your own cloud. You can run it cross clouds, or you can run it on-prem or on the edge. So it does depend. You might need to change the strategies a bit, but we do have ways where you can take all of these different guards and deploy them anywhere you want. So one big area of investment for us is finding the right set of guards that work both locally and in the cloud. Sometimes that means pulling in language models or transformers from Hugging Face down to run locally. And then it's all just more of an optimization game, making sure you've got the right balance between the size of the model, the accuracy, whether or not you need to what's called fine tune it so that it actually is detecting errors that are relevant to your particular use case.
Great. So there's a question here about the configuration and context for each application model pair. And the question is DataRobot thinking about some sort of feedback or auto-adaptive configuration mechanism where the model is automatically evaluated using various linguistic tactics that could evaluate for risk and place minimal user input requirements?
Yes, so there's two pieces here I want to touch on. And the first I'd actually meant to touch on during the presentation, so I'm glad you reminded me. One area of customizability that is essential is actually taking some of these guards, the overall strategy, and then making sure that you customize them to your use case. So an example that's super, super common is making sure that you've got a guard for relevancy. You want to make sure that the user's question is on topic. It's a question about or for which the system was designed to answer. And then same with the model's response. We want to make sure that the response is on topic and relevant to the user's question. What relevancy means, though, is entirely dependent on the use case. So in the DataRobot platform, you actually get to provide that level of detail. What type of questions do you want your system to actually accept and answer? And what type of questions do you want it to block? You've probably seen countless examples in the news, countless headlines where folks have not added this guard, and people are going to a lot of these airlines, any of these chatbots, and they're just using them as free access to compute, effectively a free GPT. The second part of the question was around, Lisa, adapting it to what? Can you remind me?
Let me get in here. This was automatically evaluating various linguistic.
Yes, the feedback loop. So I mentioned this briefly, but let's go into a little bit more detail. It is important to not only get this right when you first deploy, but to recognize that systems evolve over time. The way that humans and users ask questions tends to evolve over time. As we collect that feedback, you can actually route that feedback back to your pipeline and incorporate a lot of the positive and negative answers. So the next time a model sees a similar question, it can actually reference the upvoted answers beforehand and the downvoted answers, or however you chose to define that feedback.
Great. We have a little tactical question here. What's better than maybe some of the more traditional guardrails that are already embedded in some of the existing hyperscalers? So like Amazon Bedrock as a guardrail, like what is the difference and what do we want to look out for?
Yes, I'm glad that you asked. There's a handful of differences. So the guard models or guardrails that come out of the box with a lot of the large cloud providers, the hyperscalers, they are highly generic. They are certainly effective, but they are going to defend against errors for the masses, if you will. They're going to make sure that the models don't answer questions about politics, that they don't contain expletives, they don't contain harmful or racist or sexist language. And it's all absolutely important, but they are not going to provide any guards that are specific to your use case. Something even as simple as PII or prompt injection or relevancy, and I've worked through dozens of these examples now, every single use case, I promise you, is going to need to be fine-tuned for your context. If you use any of these off-the-shelf models, even for PII, my favorite example is that any 7-digit number will always be blocked. The typical example, if you say you or me or any pronoun, that'll be blocked because the default model has that encoded as potentially sensitive or confidential, personally identifiable information. 7-digit numbers happen to be the length of India's equivalent of our social securities, SSNs. Again, automatically blocked, even if it's a legitimate number. So you do need to come here and customize it. And that's one big value add from our platform. The other, if I go back to the earliest example that I really like, I showed you the personalized email campaign. You're going to need specific guards. So in that case, one error we ran into is that these language models oftentimes abruptly finish their output. So they'll produce an incomplete email, or even worse, they'll provide placeholders. And I'm sure you've seen this too when folks build manual campaigns, they might say dear or hey, and then they'll have open brackets or insert name here. Or they'll have a price that'll be a $sign with a bunch of X's because they needed to fill it in after. Language models, believe it or not, do the same thing. And it's really hard, even with some pretty advanced prompt engineering, to prevent that 100% of the time. So a great guard is just making sure the email is complete and free or absent of any placeholders. That's one example, but there are dozens for every use case, and those will never be prioritized by these hyperscalers because they're different every time you tackle a net new problem.
Brilliant. Of course, cost as a question is always going to come up with generative AI. It's inevitable, just because it isn't like a predictive solution, which is sweat equity. Does adding guardrails or detecting hallucinations tend to add more cost to a generative AI solution or application that you're generally developing?
It really depends. One of my favorite guards that I didn't discuss actually is looking at the length of the prompt or the response. So you can actually add guard models that are rules-based or predictive model-based that are really cheap to implement that will prevent some of these responses that we expect will consume a lot of tokens, which is particularly helpful for cost controls. At the same time, if you choose to run a lot of these response guards through additional language models, then costs can increase. But again, the key here is a trade-off. You are preventing hallucinations, and the cost of a hallucination is orders of magnitude more than the cost of the incremental cost of the additional tokens you're going to consume. And the other big piece here is that typically we see a fairly negligible increase in cost because we don't need the Cadillac of these models, the really large language models, to serve as guardrails. You need really small, hyper efficient, super customized versions. And those ones are incredibly cheap, where you pay very, very little for a whole lot of tokens.
Great. There's another question on the accuracy of the guard models themselves. How do you ensure that and look at what is the things that you have to worry about in terms of deterioration over time?
Yes, this is why you need a monitoring system. So it's important to get it right in the first place. And the best way to get it right, unfortunately, is to test during the development phase. So you need to collect examples, you need labeled examples, and then you need to be able to both subjectively with humans in the loop and objectively with some automated assessments that we offer, provide some type of evaluation or score. So you know which of these different techniques catch the most errors. And then over time, I'm sure everyone here is familiar with this idea that there's no free lunch, and it works for predictive. It was invented, in fact, for predictive models. It is impossible in advance or ex ante to know which model is going to work the best. It's the same idea here. You really don't know which guard model is going to work the best. The best way to do it is to empirically test it. So once you figure out what works the best as of today in production, you deploy those, but you carefully monitor and track them over time because the world evolves. People start using your system differently. They ask different questions. Your context data gets stale and becomes out of date. So the errors actually can change too in ways that your current guards can't necessarily adapt to. So you'll need to actually bring in new ones.
Perfect. There's a question around language support. Any other languages that are not English from a guardrail perspective and DataRobot's ability to support them?
Yeah, it's very important, and it's actually another good point back to the standard large language models and some of the off-the-shelf guards that come with the hyperscalers. They are typically over-indexed on English, and when you try and leverage some other languages, especially languages that are a little less frequent or come up a little less often on the internet, they tend to fall over quickly. That's when you need some customized models as well. So we've seen this for Japanese characters, we've seen this for Arabic, we've seen this for other languages as well. In DataRobot, we like to customize everything, and we do support every language I've ever come across, at least officially a few hundred. So it is important to make sure that your guards scale across languages too, for sure. With DataRobot, we actually have separate guard models for different models, for different languages as well, for ones that we know really necessitate that. So you'll actually see in the platform when you pick a guard, you can choose, for example, to apply it to Japanese specific tokens, since that language obviously works a bit different since it's character based.
Great. We have just a few minutes left, so please get your questions in, and we will try and do our best to answer them as we can. But before I get that, I want to thank you for all your time that you took with us today. I hope it was valuable. If you'd like to book a demo and actually see all of this in action, you can go ahead and visit us at datarobot.com/demo. Also, if you have any additional questions, please ask them in the chat. We can have our team reach out to you and try and address any of your concerns and questions as well. So just a few more here, Justin, and we want to be mindful of everyone and respect everyone's time. The guardrails, do they actually prevent streamline the text responses that users are getting, or what's the balance that how we work with them?
Yes, this is another advantage of ours, one of our differentiators. If you are familiar with working with any of these really popular language models, think Gemini or OpenAI through ChatGPT, you realize that all of the answers are streamed. And part of that is because the underlying language models are producing one token or word at a time. So you don't need to wait for the entire answer to be generated before you start sharing results with the users. In DataRobot, we can actually choose to apply the guards either to the entirety of the response or to the individually streamed tokens. And it does depend on the guard. So as an example, if you're looking for toxic language, as soon as one token is deemed toxic or one word, you can actually prevent the whole process. You can save costs and get an answer back to the user more quickly. But if you're looking for something that might be trying to decide whether an answer is correct, you might want to wait until the entire answer is generated before you then pass it back to the user. So it is up to you to decide and configure, but we absolutely do support applying these guards to streaming as well.
Perfect. All right. Well, thank you all. I want to be respectful. I know we went a little bit over, but you had a lot of great questions. We want to make sure we got them all. So again, thank you for your time. Appreciate you spending it with us and hope you learned something about LLMs and hallucinations. All right. Take care.
Thank you all.